Dear students, welcome back to the video lecture number 5 of module number 4. In the previous video lecture, we come to know the discussion on boiler troubles. Under this title, we have discussed on boiler corrosion, causes for the boiler corrosion due to the presence of dissolved oxygen, dissolved carbon dioxide, and dissolved magnesium salts by taking an example of magnesium chloride, and also we come to know the some disadvantages of boiler corrosion. Moving to the next part of this concept is dissolved oxygen. As you know that oxygen is the precious compound for the survival of any living organisms that are sustaining their life in this planet. As you know that atmosphere contains the oxygen gas, so which is essential for all the living organisms that are surviving in the atmosphere. But the living organisms, they sustain their life in the water. They needs the oxygen in the form of dissolved state. Hence, what is the meaning of dissolved oxygen? The dissolved oxygen is a measure of how much oxygen is dissolved in the water. That means that is the amount of oxygen is available for the living aquatic organisms, or it is also defined as the amount of free molecular oxygen is present in the water. And dissolved oxygen is always expressed in terms of milligram per liter of molecular oxygen. Why it is essential to measure the dissolved oxygen? As you know that the aquatic lives like fish, starfish, shark, etc., they are surviving their life in the water. So they need the molecular oxygen which is present in the dissolved state. But not only these these living organisms, but some microorganisms or biological organisms like virus, bacteria, etc., they are also sustaining their life in the water bodies by taking the dissolved oxygen to break down the organic matter present in the wastewater for their growth. These microorganisms, which are leading their life by using the dissolved oxygen present in the water, they are termed as aerobic bacteria or aerobic microorganisms. So these because of using the dissolved oxygen from the water, the oxygen level in the water body is reduces. If the amount of free dissolved oxygen in the wastewater becomes very much low, the aerobic bacteria are not going to survive their life in the wastewater. They will definitely die. So this is because of what? Reduction of the dissolved oxygen content in the water sample. Hence, the presence of oxygen in water is the good sign. But the absence of dissolved oxygen is not good sign for the any living organisms which is sustaining in the water. Not only for the living organisms which are sustaining in the water, even though for consumption of water for the drinking, if the dissolved oxygen level is too much less, then that water becomes unacceptable for drinking. So hence we need to know that how much is the dissolved oxygen content must be present for the acceptability. If you want to say the water is healthy water, it should have the dissolved oxygen concentration above 6.5 to 8 milligram per liter. What do you mean by healthy water streams? The healthy water streams, like the examples of lake, river, etc., where the dissolved oxygen level must be up to 8 milligram per liter or 8 ppm. As per Bureau of Indian Standard, the desirable limit of dissolved oxygen level must be up to 4 to 5 milligram per liter for the survival of aquatic life. If the dissolved oxygen level comes down below 4 milligram per liter or ppm, the survival of aquatic life becomes very difficult. That makes the death of the microorganisms or living organisms in the water bodies. Hence, the quality of water becomes poor if the dissolved oxygen level is reduces too much. Then how to determine the dissolved oxygen level from the water? There are the two parameters are there for the measurement of dissolved oxygen level in water bodies. There, the first one is biological oxygen demand, or it is also called as biochemical oxygen demand. Second one is simply chemical oxygen demand. Let us begin with what is biological oxygen demand. Here the word demand is nothing but compulsorily required or needed oxygen. So hence biochemical oxygen demand or biological oxygen demand means what? Biological means the living organisms that are sustaining their life in the water. They are what? Biological components. But here the biological components we are considering the microorganisms. They are present in the wastewater for to break down the organic material. As a result, the dissolved oxygen level gets reduces. It is coming down when the days or time gets passes. Hence, it is very much necessary for us to determine the dissolved oxygen level from the water by one of the technique what we are using here, biochemical oxygen demand or biological oxygen demand. So what is meant by biological oxygen demand or biochemical oxygen demand? It is nothing but the quantity of dissolved oxygen is needed or demanded by the microorganisms to break down the organic material present in 1 liter or 1000 cm cube of the water sample at 20 degrees temperature and for the period of 5 days. I repeat once again, it is the quantity of dissolved oxygen needed or that is demanded by the microorganisms to break down the organic material present in the 1 liter or 1000 cm cube of the water sample at 20 degrees Celsius temperature and for the period of 5 days. So it represents the quantity of oxygen which is consumed in the course of aerobic process by the microorganisms for the degradation or decomposition of the organic material. Next is what? The BOD, therefore, it provides the information on biologically convertible proportions, means biological components like microorganisms, what they are present. So, biologically convertible proportions of organic content of a sample of water. So, BOD is also stated in terms of milligram per liter. It is usually measured for the period of 5 days. Why the 5 days period is given for the analysis of BOD? So, BOD5 is adopted because of what? To compromise the between of a short test period and long test period. Here, the short test period for the detection of organic matter present in the waste material, that is only 5 days. Hence, determining the values of BOD for 5 days is the accepted period for the detection of organic matter present to break down by the microorganisms. While calculating the oxygen demand, the compounds of carbon are taken into the account. This stage is almost completed in 5 days. This stage is almost completed in 5 days, which means that is the most of organic content of the sewage is oxidized under aerobic condition in 5 days. Hence, the BOD is calculated for the period of 5 days. With the domestic effluent, the temperature is what? 20 degrees Celsius. Complete degradation of any organic matter for the detection of BOD 100%, it is achieved only after 5 days of time. And it is estimated that after the 5 days, 70 percentage of biological convertible substances have been broken down into the water. Hence, we are accepting the BOD determination for the period of 5 days. And the temperature is mentioned 20 degrees Celsius because of what? Is the optimum temperature where microorganisms can actively degrade the organic matter present in the wastewater. So this is about the determination of BOD, and the experimental method of determination of BOD is not for the syllabus. Hence, this is what about some important points related to BOD analysis. Then moving to the second type of oxygen present in the water can be determined by the chemical oxygen demand technique. Here in this method, we are going to measure both biologically oxidizable and inorganic matters in the water sample. I mean to say that this chemical oxygen demand determines the organic oxidizable and inorganic matters present in the water sample. Now, what do you mean by chemical oxygen demand? It is the amount of oxygen required by the both organic and inorganic matters in 1000 ml of wastewater using strong chemical oxidizing agent like acidified K2Cr2O7 for repluxing 2 hours. I repeat once again, it is the amount of oxygen required by organic and inorganic matters in 1000 ml of wastewater using a strong chemical oxidizing agent like acidified K2Cr2O7 for repluxing in 2 hours. So this is what about the definition of COD. Now let us discuss about the setup of COD determination. What can observe in this figure? We have mentioned that it requires reflex condenser where you can pass cold water at one end and warm water can be removed from the other end. And you have the RB flask for to make the reaction of reactants. And here you have the heating mantle or the heater for to heat the reaction mixture. Now let us discuss about this is what about the experimental setup. In this what can observe, we have taken known volume of water sample of waste mixed with the reactants. The reactants are nothing but here we are using potassium dichromate with required quantity of dilute sulfuric acid and adding 1 gram of mercuric sulfate and 1 gram of sulfur sulfate. Here mercuric sulfate acts as the catalyst, and the silver sulfate it avoids the interference of chloride ions in the determination. And this RB flask is taking these all reactants and it is fitted with reflex condenser and it is heated continuously for about 2 hours. After heating process is over, it is observed that the concentration of reactants are going to be changes. The same diagram is shown here about this chemical oxygen demand for the performance of the estimation. Here what can see that RB flask is taken, fitted with reflex condenser where you can observe that the entry for the cold water and outlet for the warm water. And here this replace condenser is placed over the heater and it is heated for continuously 2 hours by taking the reaction mixture into the round bottom flask. Now what is the principle is used for the determination of chemical oxygen demand from the wastewater sample? A known volume of wastewater sample is reflects with known concentration of known volume of K2SO7. It is diluted with the dilute sulfuric acid medium. Then adding 1 gram of silver sulfate act as the catalyst and 1 gram of mercury sulfate act as the catalyst and 1 gram of silver sulfate avoids the interface of chloride ions, and the reaction mixture was refluxed about 2 hours for complete oxidation. A part of potassium dichromate is used for the oxidation of impurities. The remaining unreacted potassium dichromate is used for the titration with standard ferrous ammonium sulfate solution by using the ferroin indicator till the color changes from blue-green to reddish-brown. That is what the principle of the estimation of COD determination. Now this COD determination involves the two important steps. The first one is the sample titration, second one is the blank titration. So in sample titration what we are going to do, we'll take known volume of wastewater and it is fitted with the round bottom flask and adding the known concentration of K2Cr2O7 with dilute sulfuric acid. Then adding 1 gram of mercury sulfate serve as the catalyst and 1 gram of silver sulfate avoids the interface of chloride ions in the analysis. So this flask is reflected with replace condenser and the reaction mixture is what? Heated continuously for 2 hours. After the 2 hours heating process is over, the contents from the RB flask are what? Cooled and transferred into clean conical flask. Then add 5 drops of heroin indicator, titrate with standard FA solution. Still the color changes from blue-green to reddish-brown. And note down the volume of FAs used for this analysis is what you can observe taken as the ACM cube. This is about the sample titration. Then what is meant by blank titration? The same procedure what I explained for the sample titration, instead of taking the wastewater we need to take here the same volume of distilled water and repeat the same procedure for the analysis. What is the procedure we have followed in the blank titration? Take known volume of distilled water into RB flask, adding known volume of known concentration of K2SO7 with dilute sulfuric acid, adding 1 gram of mercury sulfate and 1 gram of silver sulfate, then reflux it for continuously 2 hours. After the reflection, unreacted K2SO7 is left, which is titrated with the standard FA solution by using ferroin indicator. Still the color changes from blue-green to brick red. Note down the titration reading as BCM cube. After this, we need to go for the calculation of COD analysis. COD of wastewater sample can be analyzed by this equation. What is that? Chemical oxygen demand COD is equal to N into the bracket B minus A divided by V into 8 into 1000 milligram per liter. Here what is N stands? N stands for the normality of FAS. V stands for the volume of wastewater sample taken or distilled water sample is taken. Then what is the A value? A value is the volume of the FS used for the sample titration and B is the volume of the sample F is used for the blank titration. So with this calculation, we are going to calculate the chemical oxygen demand of the wastewater sample present in the wastewater analysis sample. So with this, I conclude the video lecture number 5 by the determination of chemical oxygen demand. Thank you, one and all. We'll move next video on next concept in lecture number 6. Thank you, one and all.